Hey folks, this is Todd Coburn with your Advice from Industry series. Today we're going to hear from Isaac Saeed and get his perspective on academia, education, and industry work and success. Enjoy. Thank you, Isaac, for joining us today and giving students and other industry professionals your perspective on work, education, academia, preparedness, balance, all of these things. The first thing, maybe just introduce yourself.
Sure. Isaac Saeed. I am a previous student of Copernicus Maximus on the screen here. I graduated Cal Poly 2015, did a master's after that, focus on structural analysis of semi-monocoque aircraft. And I am now working at Amazon in their Project Kuiper, developing the satellite constellation.
Great. So real quick, I'm going to ask you about your work experience in a moment. Could you tell us what your education is then, what your degrees are, what your credentials are for what you're doing?
Sure. Graduated from Cal Poly in 2015 with a Bachelor's of Science in Mechanical Engineering. Proceeded on to Masters after that, also at Cal Poly, with a focus on solid mechanics. Additional educational credentials. I've got a few certifications from industry training that I've done specifically in NASGRO and a few material removal from some CNC training. But Bachelors and Masters is it.
You got your bachelor's at Cal Poly. That was the mechanical program?
Correct.
And your master's was also with mechanical?
Correct.
How did you like those two programs?
I enjoyed them rather thoroughly. I enjoyed them. Yeah, it was a bit of a challenge. I can't say I wasn't jealous of some of the business majors and other majors partying on the weekends when I was stuck up in a library, but I enjoyed it. When you love what you do, it's good.
Awesome. So we're going to actually circle back on that in a moment. But what I wanted to ask you for next is just to kind of briefly summarize your work experience from any internships present.
Sure. Work experience. I began working when I was at Cal Poly by making a request to one of the professors that I was looking for a job. It's funny now that I look back, I realize that most of my career development has been through word of mouth, knowing somebody. But in 2013, Professor Stover, who was at the time the head of the Cal Poly Formula SAE team, got me an interview at a company in Pomona called FDS, which does manufacturing of paper products, plastic injection molding, thermoforming plastics, a whole host of manufacturing capabilities. And I came in there effectively as an intern and began doing machine design and whatever ancillary tasks they needed to support their production line. After that, I got an internship through the Cal Poly Career Fair with RBC Bearings in Compton. And I moved on there for the summer. That was my first exposure to industry in a professional perspective, coming in, going through the interview process, needing to get accepted. So another strong recommendation, which we may touch on later, is getting an internship. It's very important. So to continue on the progression, after that, I took a structural analysis class from you, and for some odd reason, you thought that I may be a good candidate to work for the company that you were consulting on, which was US Technical. You were doing, the company does structural modifications of primary structure of commercial aircraft. And I am very happy that I accepted your proposal to begin working, because that was my first step into the aviation industry, aerospace industry in general. At the Bearing Company, they've produced parts for the aerospace industry, but it wasn't aerospace design. So at US Tech, I believe I spent about 4 years there. I came in and was delved headfirst into aerospace analysis and design. It was all new to me. I had precisely zero familiarity with anything regarding aircraft, the way that structures were built, what primary structure actually meant, what a ring frame or a stringer or a skin was. I had precisely no knowledge. So the learning curve was steep. So continue on the career progression is after that, I wanted to move away from aviation and I wanted to go into space hardware. And so I filled out an application for a position at Virgin Orbit, which is a company under Richard Branson, and they're doing light payload to orbit from a launch vehicle that is dropped from a 747 aircraft. If you haven't seen the configuration, look it up. It's rather impressive, a reasonably unique idea. It's similar to some other programs that are out there, including Pegasus. I worked there for a few years. I was the RE, the responsible engineer for a avionics mounting structure on the second stage of the vehicle. I was also the RE of the primary release structure for that separated the aircraft, the rocket from the aircraft. After I got finished attempting to bring success to that program, I came to Project Kuiper. They're up in Seattle, and they are attempting to develop a satellite constellation which has 3,600 satellites, which will orbit in a number of shell orbits around the globe and provide global high-speed, low-latency internet. And that's what I'm doing currently.
Wow. So, did you feel your education prepared you for your job, if so far, and if so, what ways, or if not, why not?
It's interesting. It goes back to the discussion people often have when they're learning algebra for the first time. Is you ask yourself, when am I going to see an X in the world or a Y in the world? And why the heck do I need to learn how to manipulate these things? Now, students and youngsters ask those questions because they don't yet have the perspective of the utility of the information that they're learning. So I often ask myself the same thing when I was going through undergrad. Why am I learning this? Now, the key of in my perspective, the function of an undergrad program is an attempt to do two things. One, expose you to a broad variety of topics that are practically implemented in developing aerospace design. Two, it's intended to develop a thought process. And that is possibly the most important thing that you are developing in an undergraduate program. You are developing the process for how to think, how to approach a problem, understand what the requirements of a design are, and figuring out how to implement a solution. That process is the most valuable thing that you gain from an undergraduate program. It's not necessarily the memorization of torque specs and K factors and items like that. It is the process. It's similar to the difference between a cook and a chef. A cook is familiar with ingredients. They can follow a recipe. They can produce a dish. A chef has a different level of perspective on the way ingredients should interact. And when they're being told what to do by the chef, they might not always understand why they're being told. But yeah, the key is to continue getting exposure so that you can get that chef level perspective.
So do you feel that your education prepared you or didn't prepare you?
My education did prepare me. Now, it wasn't necessarily solely the information that was learned from the textbooks that prepared me for work in industry. When we say education, there's also a process associated with education, which is going to school, being a part of extracurricular activities. And that process as whole prepared me. It comes to the other recommendation that I often provide to people in undergrad is get involved in a program. I know I was told this as well when I was an undergrad and I didn't understand the value. And I did do it, and I was a part of Formula SAE for a number of years. But I only now realize the value of that process. It's arguably more valuable than the work you do in the classroom.
Now, you were involved in a lot of club work early in your academia journey. Could you tell us about that and how that either aided or didn't aid or both your development?
Sure, it absolutely aided. It's incredibly important. So being a part of the Formula SAE team is a reasonably similar analogy to the development process or what you're going to be exposed to in industry. Is you're going to have a set of individuals that are tasked with solving some problem, and you're going to need to learn how to work together to get those problems solved. Now, that type of experience isn't learned in the classroom. Yeah.
Did that have an effect on your GPA or any other pieces of your credentials?
Probably not. There is a time commitment associated with joining a club. But the interesting thing is that time is never the limiting quality in this world. It's always energy. You can get a phenomenal amount of work done in a short period of time if you have the energy. So some people had the problem that the time that they were spending on the Formula team or any of their clubs was taking away from the time that they could spend studying. I found that those things weren't necessarily mutually exclusive. And if you want to learn and if you want to be great, you make time. You make time.
Okay. So let's say in the light of Back to the Future, you had to retrace you just woke up and you were back starting your college career. What would you do differently or the same? Anything?
Good question. I feel the approach that I took was actually reasonably effective. And it was based around one item, and that is exposure. Exposure is arguably one of the most important things that you can do when you're an undergrad. I took absolutely every opportunity to expose myself to the processes of manufacturing, of analysis, of everything engineering related. And that manifested in that I linked up with Professor Davis. He is a manufacturing engineer at Cal Poly, and he would often set up tours, facility tours. So even when I was not in his class, I made a request to him to come join his tours. And being exposed to facilities that do anodization and forging and casting and a whole number of processes, that is invaluable exposure. I've said this a few times to some people, and maybe I should keep my mouth shut, but you don't want to be one of those engineers that doesn't know how to turn a wrench. We are in the business of hardware development, and many of you will go into the analytics side or the software side. Even so, you need to expose yourself to those items that you're going to be developing in the future. So if you're a hardware guy, get as much hardware experience as possible.
Great. What would you say are the keys to success in undergraduate studies?
Keys to success.
Or are there any?
Yeah, it's tough. I would say that undergraduate was more difficult for me, certainly than masters, and more difficult than the work that you will experience in industry. It's a very challenging time. You are flooded with a fire hose of information that you need to learn how to sift through and synthesize new. It's it's very difficult. So I would say tenacity is probably the one thing that is of most value. You need to just keep working. There's no substitute for elbow grease, and as much as that's true in undergrad, it's also true in industry. Sometimes you got to just keep your mouth shut and keep working.
How about what are the keys to success in industry?
Ooh, now that's a different question. So this is something I wish somebody would have told me. I'm not sure I fully comprehend it myself, but we all have a specific skill set that is inherent to us. And if you take the time to understand the overlap between your skill set and your interests, that's where you should focus all of your efforts. I wish I would have had a better understanding of that, and I would have been more laser focused on developing my structural knowledge. But the sooner you figure that out, the better you're going to be in industry, because in industry there's a whole host of positions, and each of those positions require a different set of characteristics to be successful. If you want to work in HR, you need one personality type. If you want to be a manager, you need a different set of skills. If you want to be a sole contributor, analyst, a designer, different set of skills. So figure out what it is that you're good at and what it is that you like, and focus on developing those characteristics. If you find that you already have exceptional interpersonal skills, but you have an interest in the technical aspects of aerospace design, maybe technical program management is the right place for you. So target a position that supports what you already have.
Awesome.
Because success is very much position dependent. What is considered success for an analyst is an entirely different scale of what's considered success for a manager.
Great. So is there anything else that you would like to share with undergraduate students?
Tough one. Yeah. Yeah. So depending on where you see yourself, the first 5 years of your career in industry are going to be rough. And for me, that was the case. And the reason is because the learning curve is so remarkably steep. The quantity of information that is out there is absolutely phenomenal. And you're not going to be able to be an expert in everything, unfortunately. So I think what I did was reasonably effective, although they're a bit of a double-edged sword, is I considered myself to be a bit too hyper-focused in the first 5 years of my career. It was great from the perspective that my capability increased at a rate that was greater than those people I was working with. But it does have the drawback of consuming your life. So that work-life balance is a tough thing to achieve. The question is figure out what your objective is. If your objective is to be an amazing engineer, then it is worth the investment of being hyper-focused for at least a short number of years. I will say that after that 5-year period, your capabilities will increase to the point where your job gets easier. Learning is by far the most energy intensive part of engineering. The implementation of the knowledge you already have is almost trivially easy. And there's a threshold at around the 5-year mark where you begin transitioning from the hyper learning phase to the implementation phase. I would also suggest you, not sure how to phrase this properly, make sure you focus on the development of interpersonal communication skills. Success in all positions is dependent on how much people like you. So nobody wants to work with a high performing jerk. So it's certainly something that should not be neglected.
I do. I had a couple of those working for me. Didn't get a lot of work done.
That is true.
It does wear on you a little bit.
Mm-hmm.
Yeah. I found I can work with nearly anyone. Folks with really low skills, if they're willing to work hard, and folks that are very gifted, even if they're a bit hard to work with. That's great advice. Let's see. So you touched on balance. Is there anything else that you want to add to like the whole work-life balance thing?
It's tough. It's not easy. It's not easy. I think the balance is easier to be struck in different industries. It depends on the industry. Different industries require a different level of commitment, and aerospace unfortunately requires, I think, a high level if you want to be great.
You shared about what else you wanted to share with undergraduates. Was there anything else you wanted to share with young industry professionals?
Yeah. Spend the early years of your career being a sponge and being a humble and quiet sponge. Don't, just because you got a degree, it doesn't separate you from anyone else that's sitting at any of these desks. So keep your mouth shut and keep your ears open. Do that for a few years. I promise you, you will get benefit from it. It is true, and that's something that I learned as well, is learning when to speak. For those of us that are highly energetic and got a bit of sharpness, it's easy to want to contribute to every conversation, but you don't have to. You'll learn throughout the years when to speak and how to speak. Don't rush it.
Well, hey, thank you very much, Isaac. There's been some great stuff. Is there any last things you want to share with folks?
If you don't love engineering, find another profession. You gotta love it.
Awesome. Yeah. Hey, thank you very much. That was great. And go out there and do great things.
Yes, thank you for the time.
You're most welcome. Take care.